हेलो एवरीवन। आज मैं आप लोगों के साथ एक नया टॉपिक शेयर करने जा रही हूँ जिसका नाम है ट्रांसलेशन। ट्रांसलेशन इट इज़ ऑल्सो नोन एज प्रोटीन सिंथेसिस। प्रोटीन बनाने के प्रोसेस को हम ट्रांसलेशन भी बोलते हैं या प्रोटीन सिंथेसिस बोलते हैं। ट्रांसलेशन इज द प्रोसेस इन विच वी कन्वर्ट न्यूक्लियोटाइड सीक्वेंस ऑन mRNA इनटू द सीक्वेंस ऑफ प्रोटीन। सेंट्रल डोगमा ऑफ लाइफ एक्सप्लेन करता है कि जब डीएनए से डीएनए तो रिप्लिकेशन, डीएनए टू आरएनए इज कॉल्ड ट्रांसक्रिप्शन, and from RNA to protein it is known as translation. So the process of formation of protein or synthesis of protein is known as translation. Before starting the process of translation, we need to follow some step. In first, we need to activate our amino acid, and second to form the charged tRNA. The activation of amino acid, before the process of translation we need to activate the inactive amino acid. Inactive amino acid is activated in the presence of amino acyl synthetase enzyme. It convert amino acid into amino acyl AMP. This is the activated amino acid and it plus 2-phosphate. So inactive amino acid is converted into amino acid. The different amino acid have different type of amino acyl synthetase enzyme and its enzyme for its activation. As we all know that there are 20 standard amino acid or essential amino acid participating in the formation of protein. And second step required for translation is formation of charged tRNA or loaded tRNA. A activated amino acid carrying tRNA is called loaded or charged tRNA. tRNA have amino acid attachment site where activated amino acid is attached. You can see clearly in this diagram. It is the diagram of tRNA. tRNA have a site where amino acid is attached, and the amino acyl AMP, this is the activated amino acid, and activated amino acid plus tRNA then it form amino acyl tRNA, and AMP plus enzyme is also released. This amino acyl tRNA, this is known as loaded tRNA or charged tRNA. And the step of protein synthesis or translation, it consists of 3 steps: initiation, elongation and termination step. As we all know that the site of protein synthesis is ribosome. Ribosome is basically the site of protein synthesis, and ribosome have 2 unit, one is small and one large unit. In prokaryotic, ribosome are 70S, which consist of 30S and 50S, and in eukaryotic ribosome it is made up of 80S, which consist of 40S and 60S. Now the ribosome have 3 sites for amino acid binding, that is P site, A site and E site. So 70S ribosome have 3 tRNA binding site, that is P site, it is called polypeptidal tRNA binding site, and A site consists of amino acid acceptor site, or E site is the exist site. So this is the diagram. This is the largest unit, and this is the smallest unit of ribosome. It consists of 3 tRNA binding site, that is here A site, P site and E site. A site is basically a amino acid acceptor site, and P site is polypeptidal tRNA binding site, and E site is the exist site. This is the structure of ribosome. Now for the process of translation, first step is the chain initiation. To start the synthesis, flowing factor are required. Initiation factor, for translation we need some factor like initiation factor, initiation codon, energy, and charged tRNA or loaded tRNA, ribosomal unit, mRNA. This is the basic requirement for the for process of translation. So in the case of prokaryotes, the initiation factor are IGF-1, where IF is initiation factor 1, 2, 3, and in eukaryotes, initiation factor 1, 2, 3, 4, initiation factor F4B, F4C, F4D, F, initiation factor F5, 6. These are the initiation factor. And we need this initiation codon. As we all know that the starting codon AUG, energy GTP, where GTP stands for guanosine triphosphate, charged tRNA or loaded tRNA. As we have already studied the amino acid containing tRNA containing activated amino acid is called charged tRNA or loaded tRNA, and the ribosomal unit and mRNA. mRNA basically act as a template for synthesis of protein, where mRNA is converted to protein. This is all the process of translation. Now for the in prokaryotes, mRNA contains signed Delgardeno sequence, which is also called SD sequence. It is made up of 8 nitrogenous base. This signed Delgardeno sequence is made up of 8 nitrogenous base, and this sequence is present on mRNA before the start codon. So in prokaryote, signed Delgardeno sequence is made up of 8 nitrogenous base, and this sequence is present on mRNA before the start codon, and it is present before 4 to 12 nitrogenous base. This SD sequence recognizes the smallest unit of ribosome, which contain complementary sequence of signed Delgardeno, anti-signed Delgardeno. This signed Delgardeno basically recognizes the smallest unit of ribosome, which contain complementary sequence of anti-signed Delgardeno. Smallest unit attached to mRNA. And in case of eukaryotes, mRNA contains 7 mg methyl guanosine cap. It recognizes the smallest unit of ribosome, that is 40S, and the smallest unit of ribosome 18S RNA contain complementary sequence of 7 mg, the smallest unit attached to mRNA. At that time, largest unit of ribosome with the help of magnesium ion attached to mRNA. So you can see there is a difference where in eukaryotes the smallest sequence of ribosome is recognized by signed Delgardeno, whereas in eukaryotes it is recognized by 7 mg. So in the process of translation, first charged tRNA always attached to the P site. P site is parallel to initiation codon AUG. The first charged tRNA attached to P site and lead to protein synthesis, but A site remain empty. The first charged tRNA attached to the P site and it lead to the protein synthesis, where A site remain empty. So this is the structure. Now in the process of chain elongation, the second charged tRNA attached to A site. Now the first charged tRNA is attached to P site, and for the chain elongation process, the second charged tRNA, it is attached to A site. A peptide bond is formed between two charged tRNA. You can see here the in between this and this there is the formation of peptide bond. A peptide bond formed due to peptidal transferase enzyme. It helps in bond formation. The 23S RNA also help in peptide bond formation, so they are also called ribozyme. For chain elongation, it is necessary to empty A site so that the new charged tRNA attached to the A site. For chain elongation process, we need to empty this A site so that we can increase our chain. The P site need to come out. For this, P site need to come out by E site, and A site charged tRNA shift to P site and new charged tRNA attached to A site. This process is repeated again and again. What happened here? Here the one amino acid is attached here, and it is passed to P site, and from P site it remove outside from E site, that is the exit side, and the new charged amino acid attached on this side, and this process is repeated again and again, and this lead to the formation of this led to the elongation of chain and the formation of protein. Now, ribosomal translocation occur on 5:3 direction on mRNA during chain elongation with the help of translocase enzyme, and new codon comes parallel to A site, and accordingly amino acid is attached. The sequence of amino acid on protein chain is detected by sequence of codon in mRNA. This is the diagram. We can represent the process of translation. Here peptidal chain formation, peptide bond, this is the largest unit of ribosome, this is the smallest unit. Here the starting codon AUG and GUC, and this is the translocase enzyme and the chain termination process. This step lead to terminate the elongation process by stop codon or nonsense codon. The stop codon stop the protein chain formation. Stop codon are UAA, UAG, UGA, and this is also known as Ockbar, Ambler, and Apple. Now the stop codon do not have any anticodon, and they do not code for any amino acid. The releasing factor, or in short RF, help in the chain termination. In prokaryotic, there are three type of releasing factor: releasing factor 1, 2, and 3, and in eukaryotes there is only one type of releasing factor. That is 1ERF1. Releasing factor break the connection between polypeptidal chain and charged tRNA. A releasing factor यहाँ से चार्ज टीआरएनए और पॉलीपेप्टाइडल चैन के बीच का कनेक्शन को खत्म कर देता है. इट ब्रेक द कनेक्शन बिटवीन पॉलीपेप्टाइडल चैन एंड चार्ज टीआरएनए एंड दस लीड टू द प्रोसेस ऑफ टर्मिनेशन. थैंक यू.